Good morning, everybody. Hope you're all keeping well and busy. It's a lovely day down in Winchester where I'm speaking from today. And thank you for joining us for this month's webinar with the title of Red Flags That Will Trigger Your DSEAR or ATEX Review. So basically, when should I review my assessments on this subject? Thank you for joining us. As I say, I'm Andy Fowler. I'm your presenter for this morning. I'm also the Technical and Operations Director for Sigma-HSE, and you can see my qualifications and experience here. So an ex-Health and Safety Executive Process Safety Specialist Inspector and Risk Assessor, and spent the last 40 years really on this subject of fires and explosions in one way, shape, form or another. So just a little bit of preamble about who Sigma-HSE are for those of you who are perhaps joining us for the first time on this webinar. So we've got a global presence in that we've got headquarters in Winchester, but also offices in India, and we opened up a new office in the Americas, United States, a couple of years ago. And we also have laboratories both in Winchester and India where we can test the flammability and explosibility and electrostatic properties of various materials, whether that's gases, vapors, liquids, solids, combustible powders and so on. So a global presence. You can see split between the testing arm of the business and the consultancy arm of the business, where we help clients comply with legislation or design safer processes involving dangerous materials. And of course, we also provide training, whether that's to bespoke training, taking into account your specific process operations on your sites, or indeed just awareness training on anything really to do with process safety. But from today's focus, it's really around the DSEAR and ATEX requirements. So as you'd expect from a process safety consultancy, we can handle everything really associated with all elements of a good process safety management system. Whether that's identifying the hazards through chairing hazards, HAZOPs, LOPAs, these sorts of studies, PHAs, whether it's understanding chemical reaction hazards, or anything associated with the management system associated with process safety. So ensuring that what's in place, the measures that we put in place, will be effective across all stages of the process life cycle. So that's during design, construction, commissioning, operation, inspection and maintenance, and indeed decommissioning and demolition, really. So we can help on all of those aspects. And as I said, we have the laboratories as well, which are accredited laboratories against some of the test methods that are out there for determining powder, gas and liquid flammability properties, electrostatic properties of materials, and indeed a suite around screening and undertaking calorimetry and so on to get a handle on chemical reaction hazards. So that's enough of the sales job. I'll move on to the subject of today's topic, which is understanding when we need to review our existing DSEAR or ATEX reviews that we've done. So I'll cover that by looking at what is a review, why is it needed, when should it be done. I'll give some examples. We'll have a look at some of the outcomes of a review. So that's the sort of stages I'll be going through over the next 30 minutes or so. So, what is an ATEX DSEAR review? Well, when you think about it, anything associated with health and safety legislation, particularly in the UK and Europe, and indeed across a large number of companies in the world these days, It's all based around undertaking this risk assessment. We make decisions based upon the risk of a process operation or the things that we do. Okay, and ATEX and DSEAR is essentially built around the risk of fires and explosions. And all risk assessments have the same sort of pretext for their operation. Risk is a combination of the hazardous consequences coupled with the likelihood of those hazardous consequences coming about. So obviously, you know, risk will change, the risk profile will change of a process if the hazards change, the capability of a material to burst into flame or explode, or the likelihood of those hazardous consequences coming about, the likelihood of that fire or explosion occurring. And normally, you know, this risk assessment that's done under ATEX and DSEAR looks at, can we form a flammable atmosphere? You'll be aware that fire, the combustion of materials, is basically, can be simply looked at from the point of view of what's known as the fire triangle. So to get something to burst into flame, we need a fuel, something that's capable of undergoing a combustion reaction, a source of air or oxygen, because basically a combustion reaction is simply really the exothermic reaction of a fuel with air or oxygen. It's an oxidation reaction. And the flammable atmosphere is essentially just that. It's a mixture of air and fuel within certain limits. If there's too much air within that mixture of fuel and air, then it'll be too lean to burn. And if there's too much fuel, it'll be too rich to burn. So within certain limits, we can generate this flammable atmosphere. But to get it to ignite, we need to have an effective ignition source that can kick off that combustion reaction, start the reaction off, and then it'll burst into flame or it will explode. So, you know, the risk of having a fire and explosion is a combination of the probability that a flammable atmosphere will be present and the probability that when that flammable atmosphere is present, there is an effective ignition source simultaneously. Okay, so you can see if those two components are coupled together, we can get at a level of risk. And a lot of the legislation, ATEX DSEAR, is looking at where can we generate these flammable atmospheres, and that's around the concept of hazardous area classification. And the zoning that we do within hazardous area classification is essentially related to the probability or the likelihood of that flammable atmosphere occurring. And sometimes that flammable atmosphere can be there continuously, like in the headspace of an atmospheric storage tank of a flammable liquid, if the liquid is at a temperature above its flash point. Okay, then it'll be there continuously, and that would result in a continuous grade of release, and that translates into a zone 0 for vapors and gases, or a zone 20 if we're considering combustible dust. And then if we don't have that flammable atmosphere there constantly or very nearly constantly, but it's there in normal operation, for example, on the vent pipe of that tank of flammable liquid. So when we fill the tank, when we get a tanker load in and we fill the tank, vapors will be emitted from that atmospheric vent. So there'll be a flammable atmosphere generated on the outlet from that tank. Okay, it's not there all the time because we're not filling the tank all of the time. So it's not a continuous release, but it is at what's known as a primary grade of release. In normal operation, we expect it to be there. And then there can be other releases which are secondary grades of release, and these are essentially come about when something's gone wrong, when we've got a leak, when we've lost containment, these sorts of effects, where only when that fuel can be released, can it mix with the air and generate a flammable atmosphere? And that would result in, as I say, in a secondary grade of release, and that would be known as a zone 2 or a zone 22 if we're considering combustible dust. So in your existing ATEX DSEAR review, this hazardous area classification will be undertaken and which related in the zones. Okay. Then, of course, because we are still in probability land, we're looking at risk. We've done everything we can to either prevent or control the presence of a flammable atmosphere, and we've done everything we can to try and make sure that all our ignition sources are not effective, not present, by the means in which we use ATEX certified equipment, for example, within these hazardous zones. But it could still happen, and therefore, if you like, the second part of the DSEAR assessment or ATEX assessment is associated with, well, if we have this ignited event, what have we got to protect ourselves that we don't get harmed? Yeah, so we're not engulfed in flames, or we're not partaking in an explosive event. So this is around the explosion protection, really. How do we protect ourselves? How do we stop an explosion occurring in a piece of equipment that ends up sending missiles around the plant that can hurt us? How can we deal with a fireball that comes shooting out of a piece of equipment? So this can either be, generally is what's known as the basis of safety, where we have our control over flammable atmospheres, our control over ignition sources, and means of managing the ignited event, that typically are things like containment, containing the explosion within a piece of equipment so it doesn't get out, so it can't harm us, or venting, so allowing that explosion to be vented to a safe location so it doesn't hurt us, or suppression, which is effectively very quickly at a very early stage when that ignited event occurs, putting the fire out, putting the explosion out, so it's kept within the containment system. So those are the three typical things. So, you know, once part of your DSEAR assessment will define that basis of safety around those three aspects, trying to avoid flammable atmospheres, either by, you know, working under vacuum or working under a nitrogen inertion system, or working at temperatures below the flash points of liquids and these sorts of things, avoiding ignition sources, having ATEX certified equipment, whether that's electrical or mechanical, if it's present within one of those hazardous zones, and then having our explosion protection of venting, containment or suppression, coupled with explosion isolation. So if an explosion does occur in one item of plant, it doesn't progress onto other items of plant and cascade, if you like, through your processing operation as a whole. Okay. So, you know, the hazardous area classification has determined these zones, and it's also, by calculation or other means, has determined the extent of that hazardous area, the size of it, whether it goes up, whether it goes down, dependent on vapor density and these sorts of things, or how big is it? Are we measuring, you know, 0.5 meter zone around the release point, or are we talking 3 meter zone around the release point? And the whole idea really of the legislation is, if there are potential sources of ignition within those hazardous extents, then the equipment needs to be specially protected, so-called ATEX certified equipment, which effectively just means that those pieces of equipment have been designed and built to reduce the probability of that item of equipment acting as an ignition source in its own right. Yeah, so unlike a normal switch, when we turn our lights on at home, we get a little spark across the contacts every time we operate that switch, turn the lights on or off. Clearly, if that was present within a flammable vapor or gas environment, it would be most probably be an effective ignition source, and we'd have a fire or explosion resulting from that. ATEX equipment is built by using various techniques, various concepts of protection to either stop the vapours and dust coming in contact with sparking components of the equipment, or the sparking components are sort of encased either in liquids or resins or things like this that prevent the source of ignition going out into free space, if you like, and being able to ignite a flammable atmosphere. So, you know, the review is simply something that we undertake when the risk profile has changed. The legislation doesn't actually state how often a review should take place. As most legislation says, it's all based on risk assessment, and it never really stipulates how often a review of the risk should be undertaken, unless there are some instances of this. If we're talking about major accident hazards, typically, you know, in the UK, under the COMA legislation, or in Europe more widely the Supervisors legislation, that does require a formal review every 5 years. But there we're talking of you know, major accident hazards rather than what I'll describe as more general hazards, even though we're dealing with fires and explosions. You've got to remember that this legislation, ATEX and DSEAR, isn't dealing with major accident hazard sort of events. It's dealing with what I call operational weeps and seeps, things we expect to happen on our processing equipment. We expect a flange to leak occasionally. We expect a pump seal to leak. Yeah? We don't expect a 10,000 litre storage tank to just break open and release its whole contents into the bund. Yes, that can happen and has happened. And if you're doing major accident hazard risk assessments, you would consider these things. But the likelihood of those sorts of consequences are a lot lower than the sorts of smaller consequences but higher likelihood sorts of events that DSEAR and ATEX are trying to do. So obviously, because risk is dependent upon the hazard and the likelihood, then any change to the hazard, introduction of a new hazard, or the hazard is slightly changed in terms of material properties and so on, that would prompt a DSEAR review. And changes to the likelihood of an event occurring would also prompt a change in a review. So, you know, if you've had an incident, if you've had a fire, the first thing you should be doing is really carrying out an assessment of your DSEAR risk assessment. Typically, they can be done, you know, good companies, if I can describe them as that, generally have a cycle of between 2 to 4 years. They will formally review their DSEAR assessment. And again, good companies, you'll all have a management of change procedure, which should capture changes to your processing operations. And ideally, that management of change system will prompt you to consider DSEAR aspects if you're dealing with flammable and explosible materials, whether they be vapors and gases, liquids, or powders. Okay. And also, of course, you might actually be doing something really beneficial for the company and putting new processes in, installing new processes. And the legislation does in fact say that you should undertake what's called a DSEAR verification once a process is commissioned and in operation, ideally before wet processing. So, you know, many of you will have equipment that's been designed and built and you're constructing it. If it's handling hazardous materials and what have you, you'd expect the designers, the manufacturers, to have undertaken an ATEX or DSEAR review, determine hazardous area classifications, making sure that if there's any electrical or mechanical equipment present in that design within hazardous areas, then it's ATEX certified and so on. This verification is to make sure that as it's built, it does indeed fulfill the hazardous area classification that's on site. Okay. But what the legislation does say is if there's a change to the risk profile, then the DSEAR risk assessment should be reviewed. Okay. And as I say, best practice is really, even if there's no changes, every 2 to 4 years is considered suitable. Why do we need to do it? Well, to make sure that the process remains safe. Okay, we've put a lot of work, we've put our measures in place. They all need to be effective to make sure that the overall system is safe enough and we're compliant with the legislation. So it is a legal requirement. It also gives you the opportunity to refresh people's awareness of what DSEAR and ATEX is around and the measures that you've installed and how they're supposed to be operated and maintained and inspected, properly. And after 20 odd years of the DSEAR legislation within the UK and the ATEX requirements in Europe, finally the insurance companies have finally cottoned on to the fact that processes that are involving potentially flammable and explosible materials really need to have a DSEAR assessment. So we get lots of work this way of insurance companies come in to assess the risks, ask the question, have you got a DSEAR assessment? And very often, even now, they're getting blank looks because nobody knows what a DSEAR assessment is. Okay. But it's just another risk assessment. It's nothing different really, other than it's got specific requirements under specific legislation. But it will complement other process safety studies that you may have done, like HAZOP for new designs, like hazards, like what if scenario analysis, layers of protection, and so on and so forth. Okay, all of which, all of these studies, when they identify a hazard, you will write down the measures that you've got in place to prevent, control, or mitigate that hazard. Okay, and some of those measures will be specific things like having ATEX equipment, ensuring that ventilation systems perform effectively to keep the flammable atmospheres eliminated from your process, and these sorts of things to ensure the integrity of your nitrogen inertion systems, and so on and so forth. Other reasons why a review may be required, just like the review of any risk assessment, it's as good as the people on the day doing that study. I mean, we are tasked with almost an impossible task under any of the legislation because the first step in our hazard identification is identifying all of the hazards. And that can be a very tall ask to identify all of the hazards, but that's what we're tasked with. So if we forget a hazard or we don't realise there is a hazard, then of course we won't have put any measures in place to protect ourselves against that hazard or manage it. So, and it's quite easy although the legislation, ATEX and DSEAR, is relatively simple in its concept, as with most things, it can get pretty complicated very quickly. So electrostatic hazards may have been overlooked. Dust powder hazards may have been overlooked. We may not know the specific dust explosibility of the materials that we're using. We're relying on MSDSs that just tell us that a powder may burst into flame, which is very typical. But we don't actually know, for example, how much energy is needed to ignite this dust cloud. Is it a few millijoules or is it more than a joule? it makes a difference. Yeah. We could have added new processes, although hopefully using existing systems, although hopefully these will have gone through the management of change, and that will have prompted us to at least review the ATEX and DSEAR assessments. Typically, very often, DSEAR assessments focus on the routine operations, but don't necessarily focus on things like maintenance and what have you. For good reason, because for many maintenance operations, part of the approach, especially if we're working under permits and things, is to remove the hazards at source. You know, to flush the lines clear, and this sort of thing, to remove any flammable vapors and handling. And of course, our waste handling and disposal systems may not be fully understood in terms of their hazard potentials. So just a few reasons there as to why we should be doing a review. When a review is required, normally your DSEAR assessment will be split into what we define as unit operations, things like material loading and storage, or material transfer operations, or mixing and blending and grinding and so on, all of which can change. You know, performance systems of the ventilation systems installed, the extraction systems installed, may not be the same as they were when they were first put in. The materials that were handled may not be the same. And this is really important when we talk about combustible dust, where we know, if you've listened to some of our previous seminars where we talk ad nauseum about particle size distribution being important for the generation of combustible dust clouds. Yeah. So with a standard solvent, say toluene or acetone, we know things don't really change. We can have a different supplier of toluene, and really it doesn't make any difference to the risk assessment. But if we change our supplier of a powdered product and it turns out to be having a larger dusty component, you know, it's been ground more, or part of your processing operations, you're grinding the material finer for a particular product or whatever, then of course the precautions that you've got built in may now not be suitable, or may need upgrading to deal with this increased particles, with this lower particle size. Okay, and things like that. So lots of things can change, and we need to be able to get at those changes and assess them properly to make sure that the systems we're employing, the methods of preventing ignition sources, the methods of controlling flammable atmospheres, the measures for ensuring that the venting is sized appropriately, and so on, may need to change if we go for different suppliers of existing materials. So when there's a change, so when we introduce a new process, material, or equipment, if the equipment's starting to get old, nothing wrong with old things generally, there's nothing wrong with old people like me, but generally as things get old, we need to look after them better. I rattle a bit more now than I did 10 years ago because I have to take certain pills every morning. Okay, and that's a fact of life with older people. It's equally a fact of life with older equipment. You know, we may not be able to get exactly the same seals that are on that piece of equipment that we used to get because it's now getting on in years. Changes to an existing process. So as I say, you know, running the batch time longer. You're being very successful. So instead of 1 batch a day, you're now doing 10 batches a day. Yeah, nothing's changed from the hazard point of view, but your zoning may have changed now, where before you could say that it was a zone 21 or a zone 1, it may now, because of the frequency of operation, it may actually be a zone 20 or a zone 0. Okay. The way we do things might be different. We may have started, you know, adding flammable liquids below the surface of water, and that controls flashpoint really. But you know, we may change, and we may standard operating procedures may change and say, well, we add the flammable liquid into the pot first, and then we put the water on. So things like this may change. Your ventilation characteristics in your rooms or in your buildings or around the facility may change because they become more congested, or the performance falls off. Changes in your storage conditions, changes in conveyance methods. So you're still just transferring from one process to another, but you're doing it in a different way. So the risks will change, whether you're using pneumatic conveying or whether you're using screw conveyors or bucket elevators. If we change these sorts of things, then the risk assessment will change. It should prompt us to carry out this review. So when we make a change, we're looking for the impact on the extent of a hazardous area, how big that hazardous area is. For example, if we move from filling from 25 kilo bags in and then using flexible IBCs, the extent of our hazardous areas is likely to increase, because a spillage from a 25 kilo bag, we may have determined the hazardous extent is 1 metre, but if we drop a flexible IBC and cause a spillage that way, common sense hopefully sort of indicates that we'll have more than 1 metre now, and the dust may go up to 3 metres, for example. The zonal classification, as I've said, looking at the probability or the frequency with which we do these operations, the frequency with which that flammable atmosphere is present, and the type of equipment protection that we've got. You know, so very typically we find that ATEX equipment may be installed and it's certified for vapors, for flammable vapors, but then we make a change and start adding some combustible solids, combustible powders into the mix, but the material isn't certified for combustible dust. It's only certified for combustible vapors. Okay, and again, these things may prompt us to, on our dust collection systems or our vapor recovery systems, to our protection systems may need to change. The area of vent relief, for example, the suppression equipment will have been set up specifically against one material, and the distance between where the suppression equipment is installed and where the detector is installed to pick up that explosion may change if we use different types of material. So, you know, overall, our total basis of safety, all this, everything around avoidance of flammable atmospheres, avoidance of ignition sources, protecting ourselves against an ignited event, may be compromised and thus no longer valid, because we've made what on the face of it is a very minor change. We've taken out, we now get our flour, our dusty flour from one manufacturer rather from another one, or we change from a wheat-based flour to a rye-based flour, and these sorts of things can all have an impact because the particle size distribution may change. Things like the minimum ignition energy for that powder may be different. Wheat flour, for example, could be greater than 1,000 millijoules minimum ignition energy. Rye flour can be down at 50 millijoules. Okay, so we would need increased controls around electrostatic hazards if we simply make the change from wheat flour to rye flour, for example. And of course, we can have new effective ignition sources. So, you know, we need to consider, as you say in the standard, there's 13 types of potential ignition sources, but the main ones in the processing industry are hot surfaces, mechanical sparking. So if we change the seals, if we change the clearances, if we change the materials of construction, that can all have an impact on mechanical sparking. Our electrostatic discharges, and the presence of unsuitable electricals, so uncertified equipment present when it should be certified within our hazardous zones. So just moving on, we'll quickly look at some examples of when it would be required. So here's an example in silo storage, new supplier of flour. The supplier gives a data sheet with typical flammability data, and it's got ATEX rated equipment and explosion vents installed. But for your particular flour, for the flour that's been, is the use of typical flammable data acceptable? Really, it isn't, and we should know what the flammability data is of the materials that we're using. So, you know, and if we've changed those, gone over to a different supplier, take finer material or coarser material, which should make things better. Minimum ignition energies can change. Maximum pressures in an ignited event can change and increase, all of which would point to the venting area needing to be increased, and so on and so forth. Yeah. A milling units. Lots of you will do milling. So we know, for example, as the particle size decreases, so will the minimum ignition energy. It's more easy for that combustion reaction to be undertaken, and the heat conduction from that reaction is a function of particle size as well. So the smaller the material, the less it's able to conduct any heat of reaction away from the surface of the particle, and the reaction kinetics will increase. And mills obviously are therefore certified based on the minimum MIE. So if we use that mill on different products, we need to know which is the lowest MIE. And of course, if we do have changes in the materials that we use, which have resulted in lower MIE, because the change between something like wheat flour and rye flour, as I described before, or simply that the new material is dustier than the older one, then the minimum ignition energies will decrease. And if they decrease low enough, then we may need to add, as a secondary basis of safety, inerting, as well as trying to avoid potential ignition sources. Yeah, because that finer material, that material with lower minimum ignition energy, will be more sensitive to ignition. So the installed measures we've got that control that may need to be improved. On a reactor, so, you know, we all know that we can increase reaction rate if we're trying to do more batches a day or things like this, if we increase the temperature. But of course, if that takes us above the flash point, if we start increasing the temperature above the flash point, or we use a material that isn't classified as flammable, something with a flash point greater than 60 degrees C, but now we start to operate with it at temperatures in excess of 60 degrees C, it will then act effectively as a low flash material. So, or where before we may have been saying that there is no flammable atmosphere because we're operating at a temperature less than the flash point of the material, now we're heating past the flash point, so it will produce a flammable atmosphere. So we've maybe gone from a non-hazardous situation to a zone zero situation, which of course would mean that we may have to put in additional precautions to prevent ignition and so on and so forth. And in waste storage, you know, a lot of decanting of waste and things like this, but do we really make sure that we earth the containers that we're moving material in and out of? Do we still use good containers so we can get that proper sealing, so we're not having fugitive emissions of vapours out of the storage conditions? Do we sometimes break that electrostatic continuity to earth because we stick the drums on insulating pallets, or we use plastic drums that are insulating, or the floor isn't connected to earth? I mean, that flooring can be a big issue in things like food manufacturing and pharmaceuticals. Generally, a concrete floor, which we'll see in many chemical processing operations, will be earthed. But in the pharmaceutical and food industry, they tend to coat the floors with nice cleanable resin floors, many of which are not static dissipative or conductive. So you can fall into a false sense of security thinking, well, my people wear static dissipative footwear, therefore they're earthed. But of course, if they're stood on an insulating floor, they're not earthed. And similarly, in these sorts of operations, fixed pipe work is less frequently used. We have flexible hoses, which could be a potential source of ignition from an electrostatic point of view. So they need earthing, and so on and so on and so forth. So what we're trying to do from this review is make sure that the basis of safety remains valid, we're still safe, that our measures that are installed will still be effective against the materials that we are currently using or plan to use if they're different. Yeah. So we may need to get some more testing done to understand the flammability data, especially things like maximum pressure development, if we're using venting or containment as our explosion protection, things like minimum ignition energy to make sure that all potential effective ignition sources, now if they're a lot lower, we can still deal with them. If we're using inerting systems, if they change or if we don't do them properly, you know, we need to make sure that we are below the limiting oxygen concentration present, and that of course changes with the material. That can range from something like 18% oxygen down to less than 5% oxygen. And how do we ensure that? And if it's really important, we may need to consider increased integrity instrumentation around inerting systems, which we develop through techniques like LOPA and things, to try and reduce the probability of the inerting system becoming ineffective. Changes of standard operating procedures, changes of the review and so on and so forth, of the ventilation characteristics, all the things that have an impact on either the hazard or the likelihood of that hazard coming about. So it's as I repeat again, it's standard risk assessment. So don't get too hung up on this, but you know, a lot of it relies upon having a good effective management of change procedure, which people implement well and do the appropriate studies correctly. And of course, understand the things that can impact the hazard when we're dealing with flammable materials and especially combustible dusts. So I hope you found this enjoyable and worth listening to. I'll end the webinar just about now. Of course, if you'd like us to help you with a review of a DSEAR assessment, or get us in to do a DSEAR assessment if you've not got them, or ask us any questions around what I've been talking about today, just give us a ring or send us an email to info@sigma-hse.com, and we'll gladly help. So at that point, I'll say goodbye. Enjoy the rest of the day. Have a good weekend, and I look forward to meeting you again in the next month or two at the next webinar. Cheerio, and thanks for attending.